Oh, hi there. Thanks for showing up for your learning. Today we're going to be looking at these types of questions where we're asked to find two values of x where, oh, this is not plugged in. Two values of x where 0 degrees is less than or equal to x is less than or equal to 360 degrees. You see, that looks very much like a domain statement because it is. For these trigonometric functions, x could be all real numbers. So we want to limit that so we don't get an infinite number of solutions. But anyway, I'm going to show you the fast way to answer these types of questions. Okay? This is fast and dirty. This is not about let's understand it three different ways. Okay, if I give you this question, sine x is equal to negative root 3 over 2. Here's how you solve these fast. You go over here and you say, I know that I can look up in Google the unit circle. Get images for a good unit circle. Find one you like. This one I like. And then let's zoom in, look at it, move my face. Okay. So the whole point of this, wait, let's just open it in a new tab. Open image in new tab. There we go. So you get this unit circle and you go ahead and you notice that the y coordinate of all of these things is the value of sine for that angle, and the x coordinate is the cosine for those. Okay? And you are asked to find the value of sine, the value of x that makes sine negative root 3 over 2. Okay, and you can do cast rule, and you can know that sine is negative down here and down here where y is negative. And oh, look at that. There's one. Oh, sorry, you can't see it there. There, right. Can you see my cursor? I'll write on the screen. This is highly annoying. Oi. Okay, so you go ahead and you find your unit circle. I've put the unit circle down here, and we're looking for the places where sine, this value, the y value, is going to be equal to negative root 3 over 2 or negative root 3 over 2. Okay, so there they are there. And we're going to look at them. Well, this one here corresponds to 300 degrees, and that one corresponds to 240. Basically, 270 plus or minus 30 degrees. So then we write that down this way. Okay, we're looking for values of x. So you'd say x is equal to 240 degrees or 300 degrees. And then you double check it. Yeah, that is indeed the values of x that make that true. Okay, so that's how you do that one, that type. Let's just get your unit circle and look it up. We all have Google. Understanding can come later. This course is too fast. All right, if I said, go ahead and find me a secant of x that's equal to root 2, you look down here. Well, there ain't no root 2 here. There's like root 2 over 2. Now here's a little point for you. Root 2 over 2 is the same thing as saying, well, I could divide out that root 2. This is like 1 times root 2. And on the bottom, that's root 2 times root 2. And these root 2's can cancel. So root 2 over root 2 is the same thing as saying 1 over root 2. Okay, these are equivalent. And that's useful to remember the same way, anyway, or whatever. Okay, so if we know this, and we see, well, I don't see any just like root 2 on there. But of course, neither of those is giving you secant. But secant x is equal to 1 over cosine x. Just got to remember, and if you forget, look it up. So if 1 over cosine of x is equal to root 2, then cosine of x would be equal to 1 over root 2. Just flip both sides. So this is actually what we're looking for if I give you a question like that, or if the course gives you a question like that. So let's go ahead and find the cosine that has 1 over root 2. Oh, thanks, Mr. Jennings, for pointing that out, because now I can see I'm looking for cosine, so I want to find the x value, and there it is. Oh, I thought I would find it over there, but that's not it, because that's negative, and I want positive, so it's down there. So the two values are 45 and 315. Basically 0 degrees plus or minus 45 degrees. So we would say x is equal to 45 or 315. degrees. Keep going. Sure. What if I asked you for tangent? Okay, tangent of x is negative root 3. How are we going to do that? Again, the answer is in the unit circle. Let's go. This is for all of our special angles that have exact values. They're all found in the unit circle. Well, there's ones for 15 and 75, but you'll learn them next year. So I want tangent is equal to 1/3, right? Or negative 1/3. Negative 1/3. Okay. And tangent's not on the unit circle, Mr. Jennings, but it is. Watch. Tangent of x is equal to sine x over cosine x. So I want a combination of this that equals negative root 3. Okay, so I'd like a negative root 3 on the top. Let's see. Okay, here's a root 3 on top, and because that's sine, because I want that on top of my fraction. And then down here, there's a negative root 3 there. Okay, but there's also a root 3 on top over here. So I wonder which one of these three will work. Oh, wait, there's one over there too. Okay, so all of those are going to give me root 3 in some sense, but here really the cast rule is useful because, I mean, this one won't work because it would be a negative divided by a negative will give me a positive, and this is a positive divided by a positive will give me a positive. But just remember your cast rule, C-A-S-T, meaning cosine is the only one that's positive. So this will work, and I'll show you why in a second. All of them are positive, so that won't work because we want negative. Sine is the only one positive over there, so that will work. That will work. And tangent is positive down there, so that won't work because we want a negative tangent. So let's see. If we take, let's say, 120 degrees, and we look at that, well, let's see. We would have tan 120 would be equal to sine of 120 over cos 120. So that's root 3 over 2 divided by negative 1/2. And if we flip and multiply, that's root 3 over 2 times negative 2 over 1. Cancels, cancels, gives us negative root 3. So that's how you do those. That's more of a puzzle, I'll admit, but you can do it that way. Yeah, and it's not that bad. So what did we find? Well, we found that this angle here gave us the required value, so that's 120, and this one here would also do it, and that's 300. So 120, 300 are our solutions. All right. Now what if I said, well, what if the cosine of x is 0.8? And I want you to find two values to make that true. Okay, and then you're like, well, I'll go to the unit circle and I don't really see them here. They're not here. Okay, this is only for the special angles. If I give you something specific like that, you kick out your calculator, you say 0.8, but I'm going to take the inverse cosine of it. And that tells me it's 36.8. All right, 36.8. And then you're like, well, I know there's two, but I'll at least get half the marks if I just use my calculator. So x is equal to 36.9. So we're just going to round that to 37 degrees. One degree is enough for error for the most part in this course. I mean, there's times where you'll want lots and lots of, it doesn't matter. But we want another one. And so here it really helps to think about cosine as a function and to go over here and say, well, I'm looking at cosine of x, but that's not right. That's not really what I'm looking for because right now this is set in radians. I need to change the calculator to degrees if I want to use Desmos. I'm going to need to see 360 degrees of x, and cosine only goes between 1 and negative 1, so this is going to give me lots more detail like that. All right, now if we go ahead here, now we see that we can see a lot of cosine. And if I go y equals 0.8, I'll see here are my two solutions that fall in the desired domain. Okay, there's the one we found on the calculator, 37 degrees. Here's the other one, 323 degrees. Okay, 323 degrees. Now why? How do we go from what our calculator tells us, which is only one value, how do we get this second value? Okay, you got to use the cast rule and you got to visualize. If I know that this angle here, 37 degrees, is giving me the desired cosine, cosine is basically like saying, what's that x value here? Okay, and there's one other way to draw that angle with the same x value, and it's down there. All right, and that's 323 degrees. So the way you would find that is you would just visualize it and say, okay, I know this is going to be the related acute angle. I'll put that related acute angle down there. So I'm going to do 360 minus the value my calculator told me, and that will give me the required angle, 323. There's going to be tricky ones of like this type and that type that you're going to have to actually still do some thinking about, but I wanted you to have this quick and dirty find these values and move on type of thing to get you ready for grade 12. All right, any questions, hit me up by email. Bye for now, everyone.